Lesson 1.3, as the title shows, is going to be our first look at limits. All right, so we've got one example here that we're going to do together. Antonio and Deanna are working on a community pool for the summer. They need to provide a shock treatment of 455 grams of dry chlorine to prevent the growth of algae in the pool. Then they add 45 grams of chlorine each day after the initial treatment. Each day, the sun burns off 15% of the chlorine. Find the amount of chlorine after 1 day, 2 days, 3 days, and then we are going to look at the long run value. Okay, so to start us off, we always want to identify key information in a text. So first of all, this 455 grams, that's our starting value. That's our U sub 0. Okay. The next thing that we're told is that we're going to add 45 grams each day. Okay? And then lastly, we've got the 15% that gets burned off. Okay? So if it is being burned off, that means that it is going away or it's decreasing. So think of that kind of like a decay factor. So it's a 15% decrease, which we know whenever we have percent decrease or increase, we have R equals 1, and since it's decreased, it's minus 0.15. So our R value is going to be 0.85. Okay. So notice here we've already talked about adding, and we've talked about an R value, which means it's not strictly geometric and it's not strictly arithmetic. Okay. But that's okay, and that's what we're going to look at. They call this actually, and we'll talk about this in further section, but they call this kind of combined arithmetic geometric sequence a shifted geometric. So let's start with writing a recursive rule. We already pointed out our starting value, that U sub 0 is 450 grams. Now, our rule, U sub n, we said that our R value is 1 minus 0.15, which is 0.85, so we are multiplying by 0.85. But we are also adding 45 each time. Okay, so there's our recursive rule. Then we can use that rule to find the first three terms. If I know U sub 0, then I can find U sub 1. So first day, I'm going to find my first term, I take 0.85, multiply it by my previous term, which was 450, and add 45. Okay? And if you do that, you get 427.5 grams. So then continuing that pattern to find day 2, that's U sub 2. We multiply our previous term, which we just found was 427.5, and then we add 45 to it. Okay. And if you do that, you get 408.375. Day 3, continuing the same pattern. Remember, you can always use your calculator shortcut as well, and we're going to write that down up above together in a moment, but this is just so we understand really what our shortcut is doing for us. It's taking and multiplying the previous term, which we just found was 408.375, and then adding 45 to it. Okay. And so that gives us our third day, which is 392.11. Okay, and you could either continue the pattern like that. That gives us our first 3 days, but we want to look at the long run behavior of this equation. That's the last piece of this problem. So you can continue using this, or you can use your calculator shortcut. So just as a refresher, our calculator shortcut is just like our recursive rule. Our 0 term is 450. we're going week by week, so you always have answer 1 plus 1, and then answer 2, we are multiplying by 0.85, and we are adding 45. Okay, so if we can just put that in our calculator and start hitting enter, we can get some more terms that follow after the third day. Okay. And that's what we're going to do. We're going to set up a table to kind of give us an idea of how our equation behaves. Okay. So if we go from here, the 4th week, if you hit enter again, you should get 378.30. The 5th week, we're at 366.56. The 6th week, we are at 356.52. 7th week, 348.09. 8th week, we're at 340.87. 9th week, we're at 334.743. And this is not something we're going to have to do every time, but this is just setting up so we understand exactly what this relationship looks like. Okay. Notice when we go from week to week, we're still decreasing, but the quantity that we're decreasing by is less and less each time. And in fact, if you keep hitting enter, you're going to find that you never drop below 300. That's going to be what we call our long-term limit, our long-run value. It's got different names for the same thing. Okay, and this problem did ask us to graph this relationship as well. So we're just going to do a sketch. So if we're counting by hundreds, on the y-axis, and this is our chlorine in grams, and the x-axis is time, and we're talking about days. Okay, and so you can count these by 1. And we're just going to do a rough sketch here. Now, we should have, like we talked about, never crossing 300. So the way we draw in our long-term value is we can draw a dotted line there so we know we never cross it. Okay? And as we plot our data, 450 is our level after 0 days, and then immediately after the first week, we are at 427, 408, and then by the 3rd week we are below 400. So you'll notice we keep decreasing, but we are getting closer and closer to that 300 value. Okay. So that's one way you can think about the long-run limit. There's also a way to calculate the long-run limit. Okay. So if we want to calculate the long-run limit, it really takes 2 steps. The first thing we always do is we replace the u's. Okay? And the second thing is we solve for u. So if we bring down our rule from above, that was u sub n equals 0.85 times u sub n minus 1 plus 45. First thing we're going to do is replace both of those u's with a regular u. Then we just need to solve for u. So the first thing we need to do is get both u's on one side, so we subtract 0.85 u's. And think of this as a 1 u on the other side, so when you subtract 0.85 u's, you're left with 0.15 u's, equaling 45. Then we divide by 0.15 to get u alone, divide by 0.15, and you will get a u value of 300, which is exactly what we found from using our calculator and looking at the graph above. Go ahead and try the guided practice on your own, and then watch the second video to check your work.